Thanks, Irina. Our first speaker is from AngelList, which of course is perfect because that's who's hosting us today. It's Chamod, excuse me. And he's going to be talking about how they 10x'd one of their slowest parts of their application by moving spreadsheet generation to Ruby. Let's give a round of applause to Chamod.
All right, thanks everyone. I'm gonna set up my screens here. All right, hey everyone, I'm Chamod. I'm super excited to welcome the SF Ruby community here to our very own Founders Cafe. I'm a software engineer here at AngelList, and for those of you who don't know what AngelList does, we build finance software for fund managers and VC firms. When you look at how startups get funded, there's a lot of capital out there in the world, and there's a lot of startups that need that capital. But the flow of that capital is constrained by a relatively small group of people, fund managers, or in industry speak, GPs. They're the people who take money from investors and decide which startups get funded. Historically, the funnel has been really narrow because launching and running a fund is traditionally a very complex and expensive process. What AngelList does is we broaden that funnel. By making it simpler to launch and run a fund, more founders are getting funded and more people get to participate in the venture economy. To date, the funds on our platform have raised more than $15.4 billion and invested that into more than 28,000 startups. And all of that runs on the same foundation, a core Rails monolith that powers everything from capital flows to accounting. And today I'm going to be zooming in to one of the gnarliest parts of that system, which is financial reporting. And that's what I work most on. One of our core responsibilities is to generate precise, auditable Excel reports for the thousands of funds that we support on the platform. So AngelList has been a Rails shop from day one. And as the Rails and Ruby community has evolved over time, so have we. We've been able to take advantage of the great tools that the community has produced over those years. And that starts with Active Record. It's the ORM that allows us to do a lot of idiomatic querying over multiple large databases. And the Active Job Adapter, for example, has allowed us to plug and play multiple asynchronous job queues, starting with Sidekick, but more recently introducing Good Job and even Temporal for long-running workflows. And one of the greatest things I've seen is when I joined as an intern in 2023, I saw how our adoption of Sorbet back in 2022 really sped up my ability to onboard and rapidly develop features. Just the level of type safety we had in our code allowed new engineers with varying degrees of experience in Rails to come on and quickly ramp up and ship. What I'm really proud of is the engineering culture that we fostered here at AngelList. We're super pragmatic about choosing the right tool for the job. And whenever there's an opportunity to provide leverage for our developers, we take it. And that really plays into what I'm going to be talking about today. So as I mentioned, I work primarily on financial reporting. And one thing you realize over the years is in the world of financial reporting, Excel, it's inevitable. For AngelList, we produce thousands of workbooks every quarter programmatically. So just as a show of hands, how many of you have had to programmatically ever generate Excel in Ruby or in any other framework? Okay, so those of you who don't have your hands up, you can count yourself lucky. But those of you who do, you can probably empathize with a lot of the pain I'm about to go over. But yeah, these workbooks, they're consumed by multiple stakeholders. These include external auditors, internal operations teams, the fund managers, as well as their investors, because they provide insight into how a fund is doing, the money movements in and out, the startups they've invested in, as well as how those startups are doing. They provide insights such that fund managers can make data-driven strategic decisions on follow-on investments. And ultimately, because of the amount of stakeholders in this process, there's a lot of complex requirements that come out of that. The first thing is that these workbooks, they need to be auditable. It's not enough to just spit out some raw numbers from Ruby code. You actually need to show all of the individual calculations that go into producing those numbers. And as a result, what happens is your workbook ends up being this complex web of interlinked calculations. So I'm not going to zoom in here, but I got cursor to generate what our worksheet logic actually looks like. Each of these blocks is an individual worksheet, and each of the connections is like a reference. And you can see from the fact that it looks more like a printed circuit board than a diagram that it's really interlinked and complex. The next thing is like every venture fund can be structured slightly differently. And as a result, a lot of this data, it can present itself in slightly different ways, which results in us having highly dynamic generation logic, again, adding to the complexity in this process. And finally, since it's a key like customer facing product surface, we get relatively frequent changes requested by both external customers as well as internal stakeholders. As a result, our code needs to be relatively refactorable as well. So fortunately, we didn't have to write like raw XML or anything. We were able to get a great starting point with the CAX LSX gem. It models workbooks in what I would say is like probably the most obvious way. You got a set of worksheets. Each worksheet has an array of rows, and each row has an array of cells. So what you essentially have there is just a set of 2D arrays, right? It's pretty obvious. And honestly, it's better to show rather than tell. So let me just dive into what that looks like in practice. All right, so here we have a relatively simple worksheet. Just 2 columns, got your labels there and some values. So when you look at what happens in CAX, LSX, there's a bit of boilerplate, and then, you just define each row as an array. And sure, it looks relatively simple at first glance, and you just hard code your formulas in there. But let's try to now refactor it and see what happens when we try to switch the sheet to something slightly more complex. I want to introduce the secondary column to split out our expenses into 2 categories and add a couple of empty rows for readability. So gonna do this live, see what happens. All right, gonna put my mic down here. Gonna have to project my voice. All right, so we want to add that empty column first. So that's pretty simple. Just add a bunch of empty values there. Okay, cool. Now we want to add the additional rows that we wanted to add to the sheet here, which was just adding a couple rows there. Again, very simple change. Now, what I wanted to do here was to kind of create a sum of the expenses, right? Okay, again, relatively simple, but then the question comes, hey, what do I have to actually add here? Me as a developer, I have to now figure out what are the actual coordinates I'm putting into the formula here. So I got to be like A, B, C, 1, 2, 3, 4, 5. Okay, so it's going to be C3 plus C4. Again, I have to mentally load up all this context. And so, sure, I can now go ahead and update the formulas. Now I got to figure out, hey, this is no longer column B, it's column C. Got to update the cell there. And then again, got another formula here. I got to figure out where are the cell references in there. Add these up as well. Figure it out, C6. Okay, and then, oh, I forgot. I got to add these empty rows as well. So sure, adding the actual empty row, very simple process. But again, I got to now update the formulas that were below. And suddenly I have to make like almost like a dozen updates just for a very, very simple change. So like, what did I end up doing there? All these updates, and every formula that was referencing data had to be updated. And sure, it's a bit of a simple example here, and you could do some basic refactoring to make things more dynamic here, but the point still stands. When your worksheets and workbooks start becoming this complex with this level of interconnection, any simple change requires a mass propagation of changes across all your worksheets. And so like when you have worksheets that have like up to 50 columns in a financial workbook, yes, this is a real example, it suddenly becomes a very big pain. And what we realize is that this gem, it works fine for simple tables. But once your financial reports become complex enough, it becomes this very difficult exercise in string manipulation, coordinate tracking, and just dependency management in general. So you're in this state where you're very scared to make even a small change because you realize, hey, adding one column might just cause like a massive like reference error across all your workbooks. And even then, like what's more scary is like you could introduce a very subtle error and have no idea what went wrong with your workbook until an accountant comes in and says, hey, this is wrong, we ship this to the customer. Like that's a very scary state to be in as an engineer, where you're thinking, hey, I don't want to touch this code because I'm scared that it might break things. So you might be wondering, why did I care so much about this problem and why did I end up on the path towards fixing this? So gotta set a story here. It's basically a story of how I, as an intern, got very frustrated with this process and channeled all this energy into some collaborative, creative engineering innovation to yield a process that was much more novel of an engineering approach to how we can build spreadsheets in Ruby. Okay, so here's the stage. I am an intern here at AngelList's summer 2023 on the financial infrastructure team. I was working on what I thought was a relatively straightforward task as part of a larger project, which was to automate carry structures within our workbooks. For the uninitiated, carry is just a percentage of profits that a fund manager gets as compensation, like an incentive alignment with their investors. Traditionally, for most venture funds, it's just 20% of a fund's profits. But for certain funds, they stipulate some more complex terms, like you can have hurdle rates, preferred returns. Not going to get into the specifics there, but the fact is that these fund managers, they very carefully negotiate these terms. And it's on us when we produce these financial statements and for our accountants to ensure that financial statements reflect these fund structures accurately. And so at the time, prior to automating this, each new fund that we had with a more complex structure required more manual work for our accountants every single quarter. So it was definitely in our best interest to automate it. Now, I thought the toughest part of this would be like figuring out what formulas to put in. And sure, with enough deep thought and a couple whiteboarding sessions, I was able to figure it out. I was pretty like hyped and I thought I was through this trough of sorrow. But then came the process of having to implement this in our Excel workbooks. So someone told me that summers in SF are supposed to be cold, but I was getting burnt by this hell of string manipulation. So yeah, it was a good dad joke. Yeah, so when you have formulas like this getting spat out by your logic, I'm sure you guys are not going to be surprised when I say that I was getting riddled by all of these off by one errors. Any small structural change was causing my formulas to be like poorly formatted. And honestly, like making any changes to this felt super archaeological. And I brought this up to the team, but the consensus was, hey, building spreadsheets, it's just a brutal process. And at the time, we had our reporting cycles coming up, and I just wanted to ship this for our accountants to immediately leverage it to eliminate all the manual work they were doing. But I still always had this lingering thought in my head. Why did building out spreadsheets have to be so brutal? To me, figuring out the business logic is meant to be the hard part. Displaying it in a spreadsheet should be easy. And so I thought, hey, my internship is ending. I probably won't have enough time to actually deal with this issue. But fortunately, we had a hack week coming up here at AngelList's. And one of my colleagues at the beginning of that week sent me a DM that changed everything. So my teammate, Zach, he asked me, what if we could build spreadsheets just like a finance professional would? Instead of modeling these workbooks as 3D arrays, what if we treated the flow of data as a directed graph? And so just for more context, finance professionals, they get a lot of feedback from the Excel interface when they're building out these spreadsheets. And so they can just think, hey, profits equals revenues minus expenses, and then carry is just profits times 20% whenever profits is positive. And as a result, they don't have to think deeply in cell coordinates. The coordinate arithmetic is just the means to an end. So we thought, what if we could make our code look like this? And the answer to that question is Zaxel. which is our in-house Ruby DSL that we use to build all of our Excel workbooks. With Zaxel, you no longer have to deal with all of this annoying string manipulation because cells, rows, columns, and sheets are now first-class Ruby objects within the library. And so you can just speak in financial terms without having to worry about all of these implementation details. You don't even have to worry about positioning the rows and columns at all until you get to when you actually compile the sheet. And finally, thanks to the fact that we've implemented a lot of operator overloading, we've been able to kind of make our code read more like a specification. Just like a finance professional might describe their financial model in English, we're able to have an engineer trace through the code just like it was regular Ruby business logic. Okay, so why don't we dive into a live demo of how this all works? So super basic example again here, pretty much the same sheet again. And so here in Zaxel, all you have to do is say, hey, I want to add a category column and an amount column and just label it as so. And when you get to adding your rows, you just say, hey, for this revenue row, I want to add this string revenue to the category column and this hard-coded $100,000 value to the amount column. Doesn't matter what order I do it in because now everything is super targeted. You're not defining arrays, you're creating a directed graph. And so we do that for the expenses row. And then when you get to the profit row, it's super simple to define that formula because of the operator overloading that we've implemented. So we say, hey, take a reference off the revenue row in the amount column and add it to the reference from the expense row under that same amount column. And this will actually serialize. It'll serialize to something like, I don't know, equals C4 plus C5. I have no idea if those are the coordinates, but that's kind of the point. I shouldn't have to worry about that. Zaxel will do that for me. And I know that it'll produce the exact right formula to produce the right string for that profit cell. And when we get to more complex formulas like this, where you have like a product nested in a max, nested in an if, all the functional composition that we offer really makes it easy to write the code like a specification. We just say, hey, nest the max in an if block, pass in these formulas as arguments to this function, and it'll all serialize out to produce the formula that we need. All right, so why don't we step through what it looks like to refactor the code? So to be honest, this is a very simple change, and in Zaxel, it barely looks like a refactor. You just have to say, hey, let me add a new column here. It's called subcategory. Define for each row what you want to put into that column. And suddenly, that's all the changes you need to make. Sure, you want to add those empty rows, you can do that as well, but that's all. And we made those changes with much less pain than using just the CAXLSX gem. The final example I kind of want to just go through is what it looks like to have multiple sheets. So let's expand this example. Let's say we have many expenses and certain ones apply to carry and certain ones don't. We can just loop through them, define these rows and columns, place the values in. And so when we get back to our main sheet here, it's super easy to just define things like a, let me get back there. Yeah, a conditional sum. You just say, hey, I want to check the applicable to carry column from the expense sheet. Whenever the value is true in that cell, I want to add the value under the amount column on that same expense sheet. And Zaxel, again, it'll handle serializing the formula up there. And you don't have to worry about all the messy string manipulation around trying to construct this formula in real time. All right, well, before I get into how it works, I do want to address what might be the elephant in the room. Yes, the name Zaxel, it's a portmanteau of my colleague Zach's first name and Excel. Yeah, so I really like this name because the old name that we had, it never stuck. It's called Cell References. It was super annoying to write in code because the namespacing just got way too long. Fortunately, Zach is based on the East Coast, so he couldn't be here. He would have loved to tell this story. But yeah, he definitely deserved having the library named after him because he had that core insight of modeling the workbook as a directed graph. All right, so let's get into how this all works. Again, the core concept here is having graph-based reference tracking for the workbook. So all the first class objects are nodes in that graph, and then you can just have references tracked as edges. So you can say things like, hey, profit.ref amount, and that is tracking the relationship from the profit cell into wherever you're putting that piece of code. And say you want to insert a row, you do that, and the graph will update automatically because Zaxcel, it doesn't even figure out what the positioning is until you actually go into like what I quote, like what we would call like compilation. So there's a function, it's called like position rows. And when you call that, that's the only time when Zaxcel actually figures out where the positioning is. So you build your model with symbols and objects in Ruby, and Zaxcel will only walk the graph at the end. It'll traverse it, figure out all the positioning, figure out the references, and spit out the workbook at the end. No more manual coordinate tracking for developers, which is a great thing. And finally, the last piece of this is all of the operator overloading and functional composition. As you guys saw, you can just write code like it looks like Ruby, and suddenly it spits out this beautiful Excel sheet. In fact, like in certain cases, we've had code where it's like not immediately obvious that it's for Excel. And if you don't have something like Sorbet in your IDE telling you what the types are, you might actually think that it's just regular business logic, but it's actually like writing a workbook. And I think that's the best part of like how this all works. Ultimately, all three of these ideas, they interplay well with each other to produce these like idiomatic implementations that you'll see all across our code base. All right, so Zach and I, we came into the week with like a rough idea, a few competing ideas on how we could deal with all of these Excel problems. We came out of that week with a very clear vision for what we wanted Zaxcel to be, as well as a plan on how to execute it on it collaboratively. And by the end of that quarter, Zaxcel was producing our financial statements in production. And I had to go back to Waterloo to finish up school, but I was super excited to hear that by the end of the next quarter, all of our old financial statement generation code had been ripped out. And thanks to the elbow grease of one of our principal engineers, Alex, he got all the Excel generation code that was in our code base built off of Zaxcel and complete buy-in from all of our cross-functional stakeholders. All of the accountants loved having these tight feedback loops that Zaxcel offered because now, rather than taking days, if not weeks, to make major changes to our workbooks, suddenly took a developer only hours, and new engineers were no longer scared of touching this code. And now with more and more capable AI agents, we're able to really make changes within minutes. You just prompt an agent, describe what changes you want, and it's able to take advantage of the constrained abstractions of the DSL to make those changes effectively and reason about them. So I want to say that Zaxcel might not even be in the top 5 of cool stuff that we've built over the past few years. There's been a ton of cool stuff that our engineering team of only 30-ish engineers has built over time. And I'm hopeful that we can share more of those stories. So I hope you guys stay tuned. That being said, ultimately, Zaxcel has saved a lot of pain for our engineering team when it comes to building out Excel workbooks. And I'm hoping that in the near future, we're going to be able to save other engineers all around the world time with these same problems. And I say this because super excited to announce that Zaxcel is going open source. Yeah, I mean, we've benefited so much at AngelList's from the tools that the Ruby and Rails community has provided. And we want to show our appreciation and give back so much to the community that has given us so much. So you can scan this QR code. It'll take you straight to the repo. Zaxcel, it's available on Ruby Gems for consumption. And if you're interested in solving problems like these and what it's like to be part of a team of builders here at AngelList's, feel free to reach out to me. We're always looking for talented teammates and are actively growing out our team. Yeah, and feel free to contact pretty much anyone on the engineering team. And thank you all for your time here. Definitely would like to open it up for questions if we have enough time.
If you were So, Excel, there's some from here to there, it's all very positional. Can you like inspect an object, like even in RSpec, and say, this object should now be part of the sum and be referenced by these things? How does the test on these objects, what does it look like? Let's see here.
Yeah, that's a great question. So how we go about unit testing, we're able to, I guess, like query the directed graph and the relationships. So you just say, because all the formulas that you define, it's kind of nested in there. So you can say, hey, expect this, I guess, cell defined to be in this like row and labeled row and column to have this value. And it'll be able to the whatever like testing framework you have should be able to traverse the graph to do so. All right. Does anyone have any other questions? All right. Oh yeah, at the back.
Since it's all like an internal graph that you materialize, it should be possible to materialize it to like a grid or some other spreadsheet render as well, right? That's like another adapter, right?
Yeah, totally. I mean, Excel doesn't have to be the final form factor here. Like obviously, like we could write to any sort of spreadsheet solution or even like directly to the cloud. It's just a matter of like plugging and playing for sure. All right. Yep.
Is like a non-code DSL, like a non-technical person could write a description for, like number file, something like that. So, or is it all code?
So Zaxel as it currently exists. So the question was, is there a way like a DSL that non-technical people could use? I'd say the way Zaxel exists right now, sure, it's like in code, but like honestly, you could define it as like, for example, like an MCP framework and just like define all the different functions as tool calls you can make. And as I mentioned earlier, we here at AngelList's, like we've been leveraging like various, I guess, LLMs to now make changes to our workbook generation code. I don't see a reason why, especially like in an iterative loop, a non-technical person couldn't kind of prompt for those same changes and just continually generate workbooks until things work out. All right. Yeah.
One question. Is there like some validation, let's say, for like detecting like cycles in like references, or you need to generate the sheet and make it like short curves after generation?
Yeah, so there's no validation to check cycles as far as I'm aware. I have to dive back into the source code. But the interesting part is that Excel doesn't actually error on circular references. It's actually a very niche thing, but it'll try to iteratively compute the reference until it converges on some value. If it doesn't converge, then it'll error out. But there are situations where you can actually have circular references within Excel. All right, well, thanks everyone for the time here. I super appreciate it.
Thanks, Chamod. That was awesome. I love me an Excel spreadsheet. Our next speaker is Dr. Chris Fung. I think doctor is right.
Yeah.
From Binti, and he's going to be talking about a Ruby bindings to the Fjall. Is that how you pronounce it, I assume?
Fjall, yeah.
Fjall? Okay. Key value store in Rust. Take it away, Chris.
If I can make
Yeah, I got it.
Do you prefer lapel instead? Very good.
I'm good with Mike. Yeah, I don't need to code. Hey everybody, my name is Chris. I think I presented to the meetup for a little while ago. So I know a bunch of y'all. So what I wanted to talk to y'all today about is writing Ruby extensions with Rust. Specifically, yeah, like Cameron said, demoing this or showing off this little Ruby gem I wrote for wrapping this library called Fjall. So just to start out, have you ever installed a gem and seen this line in the output before? Give me a show of hands. Anybody? Yeah, y'all probably recognize this line, right? Building native extensions. This could take a while, right? So native extensions, what does that mean? Well, in a nutshell, basically, a native extension is any code that needs to be compiled for your machine specifically. So you can contrast that with pure Ruby code, which is this window. Pure Ruby code, which can run on any machine that the Ruby VM runs on and doesn't need a separate compile step. And so there's many reasons you might include a native extension in a gem, but some of the big ones are speed, first off, and integrating with a library that's not written in Ruby. The Ruby VM, MRI at least, is written in C, and that means most native extensions are also written in C or C++. But actually, other C-compatible languages work too. For example, Rust. Oh, click. There we go. So fair warning, I am going to be showing some Rust code in this talk, but don't be too scared. I'm not sure if this is totally true anymore, but I know Rust in the past has had a reputation for having a very Vim-like learning curve, meaning it's kind of just is at 0 and then it goes straight up and then you're at the top. For the code I'm going to show today, I'll try to explain as much of the syntax as needed. So you shouldn't really need to have any prior exposure to Rust to kind of get what's going on. So this talk is going to be kind of a walkthrough of a little gem that I made called Fjall Ruby to show just what it takes to write a native extension using Rust. But first, Fjall. What is Fjall? This is their logo. This is not mine. So this is theirs, and I think it's pretty awesome. If you can read Japanese, you might be able to get a little bit of a hint from the text that's under the name there. But Fjall, basically, it's an embeddable key value storage engine written in Rust. Being embedded means that instead of running as a separate process like Postgres or MySQL, for example, Fjall is a library that exposes some functions to your program. And then you call those functions to interact with the data stored inside of a Fjall database. Some of its cool features are it's thread safe, it has built-in compression, it has range and prefix searching, and also forwards and reverse iteration. And the database persists locally to a file. So it just it gets persisted into a file, which is really nice and easy to work with. If you've heard of RocksDB, which is from Meta, nay Facebook, it's like that, but written in Rust instead of C++. And another way you can think about it, it's kind of like a hash, but fast. So you might be wondering then, why would someone want to use Fjall in Ruby? And to that I say, no. We're already on this train. You can't turn around. You can't turn back now. We're going down this track. So starting a new Rust extension gem is actually really, really easy. And this is a really great development in Bundler that happened relatively recently. You can just use Bundler to scaffold out a new gem. You say bundle gem, and then you pass the --ext option and say Rust. And this will generate a really nice basic project structure for you that looks something like this. You got the normal gem files in there, like gemspec, gemfile lock. You have your lib directory, your version RB file. But then there's also this ext directory, and that has some pretty interesting files in it. So the ext directory, it contains the source code of your Rust extension, and it's structured like a Rust crate, which is basically the equivalent of a gem in Rust land. The important files that I want to touch on that I'm going to show here are the xconf or extconf.rb file, the cargo.toml file, and then the lib.rs file. So let's take a look at each of these and explain what each of them do in the native extension. So just start off with xconf.rb. So this is actually not specific to Rust native extensions. Any native gem will have an xconf file, and it's basically a signal to Ruby that this gem has a native extension. And Ruby is going to need to do something extra in order to compile or prepare the system for using this gem. If you look at other gems that have native extensions, like Nokogiri maybe, or Nio4R, I'm blanking on others, but any other gem that has a native extension, and you look in their xconf RB, it'll probably be pretty wild, pretty complicated, doing a lot of stuff to like find libraries and make sure they're in the right place and then run compilers and stuff like that. But actually for a Rust extension, it's relatively simple. We only have 3 lines here. The first one, it requires a library called makemf, which stands for make makefile. And then we require another gem or another library, rbsys/makemf. We'll talk a little bit more about rbsys in a moment, but this line here requires an enhancement to standard makemf that makes it support Rust. And then finally here we call create Rust makefile. And basically what this will do when Ruby runs our xconf, it'll generate a big makefile that knows how to compile Rust correctly and put it into the right location. So now let's take a look at the cargo.toml. So cargo.toml, it's like Gemfile, but for Rust. It basically lists your dependencies and a bunch of other metadata about your project. I've elided the package section, which normally has stuff like the package name and version number and all that kind of stuff, because it's not really important for what we're talking about today. In the lib section, then we have set crate type here to cdylib. And this basically tells Rust to, when it's compiling this code, it should compile it to produce an artifact that can be used like a C dynamic library. And so if you don't know what like a dynamic library is, essentially it's like a bundle of code that lives somewhere in the system, and then a C program can dynamically load that code. It doesn't have to be compiled into the C program directly. It can just live alongside of it. And this is important for Ruby and Ruby native extensions because Ruby wants to load its native extensions as dynamic libraries. And then finally, in the dependency section there, we have 3 items. I'll talk about the top 2, Magnus and rbsys, in a second. And then the last one there is Fjall, which is the library that we're wrapping. So then about those other dependencies, I kept promising I was going to talk about them. Magnus is the first one. Magnus is basically a Rust crate, which provides bindings to the Ruby C API. It allows Rust code to call out to Ruby VM functions, and vice versa. It also allows the Ruby VM to easily call into Rust code. The second one there, rbsys, is a utility crate, which in Rust land, it provides basically just some more lower level bindings to the Ruby VM. And closely related to that is the rbsys gem, which is a Ruby gem that makes compiling Rust extensions easier. As we already saw, it gives us some utilities that we can use to compile the Rust code a little easier. Okay, so now we come to the librs file, and this is the most interesting one. It serves as the entry point of the native extension, and it has 2 main responsibilities. The first one, define the native structs and functions, etc., that you need to implement the extension's functionality. And then the second one is to expose an init function, which Ruby will call to start the extension the first time it's required. And so we'll take a look at what that means. And instead of looking at the whole librs file, instead what I want to do is just highlight 3 patterns that I've encountered when writing this wrapper. So how to wrap a struct with a Ruby class, how to define methods in Rust that can be called from Ruby, and how to access the Ruby VM in Rust code. Okay, so the first thing is how to define classes from inside of Rust. So Rust has the concept of structs. A struct is actually not really that similar at all to a Ruby class, but it's a convenient analog, and they serve a similar semantic role. So when we're using Magnus, we model Ruby classes as Rust structs and vice versa. We model Rust structs as Ruby classes. So the Fjall crate that we're wrapping, it exposes a couple of its own structs, which are important for interacting with the Fjall database, such as partition here or key space, which is another one. And to expose these structs into Ruby, we have to create wrappers, such as this one here that I have on screen, Fjall partition. The wrapper basically, it just has a single member, just exposing the partition object or the partition struct from Fjall itself. And to expose that into Ruby, then Magnus gives us a macro called Magnus wrap. Macros in Rust, they're kind of like decorators. To use it, basically, we just need to invoke it above the struct that we want to wrap. And then the macro takes care of generating all the rest of the code that's necessary to expose this struct into Ruby. The only other interesting thing here is we specify the class name that this struct should use when it's reflected into Ruby land. So we say that this Fjall partition struct should be a Fjall Ruby partition class inside of Ruby. So once we wrap the struct, now we need to make the Ruby VM calls to actually define the corresponding objects in Ruby. And this is where that init function that I was talking about comes in. So we have this init function that's just defined in Rust. And then we have another macro invocation here, Magnus init. And this macro basically gives the function the right name so that Ruby knows to call it when it tries to require the library the first time. And so this code, it'll get run the first time the extension is required. And so it's a good place to do some bookkeeping tasks like ensuring the Fjall Ruby module exists and ensuring that there is a partition class underneath it, that kind of stuff. And that's it actually. So like with just these two little snippets of code, then we have the Fjall partition object being exposed into Ruby. So having classes is good, but we want methods too, right? Methods are what make all the functionality happen. So defining methods is actually a lot easier with using Magnus. The first thing we actually have to do is just define a method on the Rust struct. And there's no need for a special macro this time. So we just have to define a member function on the Rust struct and implement the logic. So this is an example of the name function that I'm exposing for Fjall partitions. So partitions, they can have a name, and I want to be able to like allow the Ruby callers to get the name of the partition. And so here we just define a little like wrapper function that goes into the partition and calls name on it directly. And the cool thing about Magnus here is it takes care of returning or converting the return types back and forth between Rust and Ruby. So even though here we're returning just a Rust string, when Magnus calls this function on, or when the function is called on Ruby side, Magnus will take care of converting that Rust string into a Ruby string. We don't actually have any arguments here, but if we did, Magnus would also take care of converting the arguments automatically from Ruby objects into the corresponding Rust objects. So we don't actually have to deal with any of that type conversion, which can be really like tricky. With the function defined then, so then we have to wire it up in the init function. And this happens similarly to how when we defined the classes, we just have to call this define method function on the partition class. So this partition class from before, it's like a pointer to the Ruby object representing the partition class. And we say define method, we give it the name that we want in Ruby land, and then we give it a pointer to the actual like Rust implementation in Rust land. So here we say the name method in Ruby should call the name function inside of Rust. And again, that's really all you need to do. Now the name function will be available on partition objects inside of Ruby. And calling it, we'll call this Rust code that we just saw. Okay. And then so the last thing I just want to show is how to access the Ruby VM from Rust. And we actually already saw this a little bit when we looked at the init function earlier, where we used the Ruby VM to define modules and classes and define methods inside of Ruby. Whenever we want to access the Ruby VM in a Rust function, all we have to do is make sure that the first argument to the function is of type ampersand Ruby. And this type comes from Magnus, and it basically represents a reference to the Ruby VM. And so when Magnus sees a function taking this type, it knows it should pass in the reference to the VM. And this allows us to do stuff like before when we saw define classes, define modules. but we can also do stuff like resolve pointers to specific exception classes or specific objects inside of Ruby that we're keeping in on the Rust side. So like here in the middle here, we do ruby.getInner, and then this resolves to a pointer to the exception class inside of Ruby. Okay, so we've seen a lot of Rust code, right? But this is a Ruby meetup, so where's the Ruby? And that's literally it. This is all the Ruby that I'm going to show today. With Magnus, you actually only need a very, very thin bridge to glue together the Rust code that we just saw and the Ruby world. Most of this is just the regular boilerplate that you would see in any gem. The really interesting part here is that second require, where we do require relative Fjall Ruby / Fjall Ruby. And this one is actually not a Ruby file. It's a reference to the compiled Rust code. But how does that Rust code get compiled? So we talked about xconf before. Xconf is for when your gem is installed through like Ruby gems. But the other way to do it, and I think the make file actually invokes this rake file, is with a rake file. So this is the project's rake file. Here we see rbsys pop up again for the second time. This time we're using its extension task class to basically define a compile task for the gem. And rbsys exposes this object for us to use, and it creates a task that knows specifically how to compile our Rust crate. In the block here, we tell it where the gem's lib directory is, and that's how it knows to put the compiled artifact finally inside of the Fjall Ruby folder. So then the require that we saw previously can work just like based on normal Ruby require semantics. And yeah, and that's basically it. So yeah, that's just a super quick walkthrough of this gem that I wrote. I thought it was really interesting to see how easy it is to make a native extension using Rust. I think like native extensions with C were always had a reputation of being error prone and hard to understand, very opaque, very like, yeah, just hard to grok. But the Rust code I think is very easy to read. Reading Rust is a lot easier as a Rubyist than reading C. And so yeah, I hope you give it a try. That's it. This is Crabray. Here are my links and credits. This is the Magnus gem, the rbsys gem and associated crate. And then Oxidize RB is a great resource for learning more about how to write Rust extensions for Ruby.
Any questions for Chris?
Yes.
Because this is pretty easy with Rust that you decided to.
Yeah, so I have written one C extension before. It was to a library called JQ, which is like a JSON query language. That was super hard because yeah, writing C and like understanding what was going on, and made me really scared that I was going to like nuke someone's computer or something. This is a lot easier. Rust is a lot easier to understand as a Rubyist, and yeah, I think the utilities also are a lot better than C. And C, you're just like you have to read the Ruby header file and pray.
When you call like a Rust method function for Ruby, I saw you pass in like in string value string, and that's somehow like this. Yeah, like a Ruby string is not the same thing as a Rust string, right? That's Ruby string is like represented within like the Ruby C code.
Exactly.
What if you pass like can you pass like a complex object?
Yeah. Yeah. So the question is like, like this function signature, it has like key is defined as a string type, but that's obviously a Rust string type, and Rust types are different than Ruby types. So how does this work? And can you pass other like more complex objects as arguments as well? right? Yeah. Yeah. So basically, yes, for the built-in types that come with the Rust standard library, like string and the integer types and stuff like that, Magnus defines wrappers essentially that will automatically handle the conversion between the two. So this, for a string, like when we're receiving a Ruby string, Magnus like wraps this function with some extra code that is like, oh, this is a string, I need to give it, it matches up with this positional argument, so I need to find a translator between what I got in Ruby land to translate it to the appropriate type in Rust land. So it has those translators built in for the built-in Rust types. For custom types, that's what that wrap macro that I showed at the beginning is for. If you define that on a struct that like a custom struct, then Magnus will generate translation code so that it can map it between the Ruby name and the Rust name and like transform it correctly.
Like passing an active record object?
Yeah.
It's not still even just like serialize it.
Well, yeah. So then that's like for like super complex objects like an active record object, right? Like that would be like you would have to get smart about like what are you actually passing into Rust land? Because yeah, like naively you could serialize like the whole thing and give it over to Rust, but that probably isn't what you actually want to do. So like there would be more, you'd probably want to do more thinking about like what to actually do. And Magnus gives you the utilities to define those serializers like custom for you. Yeah. Yes.
Does it work correct? Does it work correctly with ascend functions in what your runtime?
I'm actually not sure. I think like in the I'm not sure about that. So I can't answer that confidently. The question was, does it work with async runtimes? And I am not sure. Yeah. Yes.
Can you talk about an example of how you're using it?
Oh yeah, sure. So I jokingly passed over the why, and the real explanation is that there is no why. I wanted to do this, so I just did it. The less flippant reason is at a previous job, we had to load a ridiculous number of YAML files quite often as part of like the operation of the application. We noticed that like loading these thousands of YAML files was a very big like time sink in our app boot up process. And so one thing I've been exploring since then was other ways to like store hashes, like store key value data in a way that's faster to boot up and faster to access rather than file system access over thousands of tiny YAML files and parsing them all. Okay.
Our next speaker is Mr. Scott Motte. Scott is joining us all the way from the lovely city of Los Angeles. Flew up for this. Thanks for doing that, Scott. Scott is going to talk to us about dotenvx, a secure application secrets manager. Take it away, Scott.
Nice. Thanks, everyone. All right. Yeah, from LA. But it's always nice to come up here and visit. I've got friends up here. I should have probably moved up here, but I don't know. My family's in LA. So, okay. I'm going to give a little history lesson. We're going to talk about .env files. We're going to talk about their origin a little bit and maybe where they're going. And then we'll try to do a little implementation of the encryption in Ruby. So there's some Ruby here. But yeah, so let's go here to 2008. Way back, secrets used to live in code, pretty much, right? We all put our secrets in there. There wasn't that many third-party APIs at the time. This was the super early days. And then I would say came Heroku. AWS was around at the time, but it wasn't much of a platform yet. You had like S3, EC2 that I remember, and then Heroku, especially in the Ruby world, right, created this great system that you didn't really have access though to the operating system. And it started changing the way we were doing things, and especially introduced third parties, right, and API keys. You see SendGrid show up, you see Twilio grow around this time. Excuse me. So you see a lot of changes, right? And along with that is a proc file. So when you deployed to Heroku early on, and I mean, you still do, there was a proc file and you specified your processes, right? Like a process file. And you could give environment variables ahead of that to say like, I want this in production. I want this in staging for some reason. I have some other environment variable, right? And so that gets formed or becomes like a habit for deploying things, becomes a pattern. And then 2010, as people are deploying to Heroku, but still need to do development work as a team, Foreman comes out by David Dollar. And I believe he was at Heroku at the time, but basically takes the proc file and makes it like developer friendly. So now you can do this locally in development. You have a process to, you know, run Sidekick, that sort of thing. I don't remember when Sidekick came out. Does anyone remember that? It's probably around the same time. 2009? Yeah, okay. So yeah, so somewhere around there, right? And then you have, excuse me, the .env Renaissance, or that's what I'm doing for the presentation. But these are the first conversations. So you have Foreman, right? And you have this guy here, or person here, Cliff, started using Foreman. They want to set their Rails env parameter. And it's this very short discussion back and forth. And then David's like, it's like within 24 hours. Oh, let me just give you Foreman start with the -e flag, and you can pass the .env file. And so .env files were around, right? But this is probably, I would say, the first time they really get applied to applications and start being used in development and become this spot that you can put all these secrets or really config at the time. But secrets too, because you've got, you know, your SendGrid API key, you've got your Twilio API key. It all starts kind of happening here. But not everyone's using Foreman. Then you've got to, you know, run this Foreman process. Maybe you just want to run, you know, bin Rails server, or what was it back then? I guess bundle exec Rails S. Oh, and then real quick too, these same guys, David Dollar, these people at Heroku, come up with the 12-factor app. This kind of becomes big in the mind share of developers that you shouldn't store your config in the environment, right? So we went from all your config was in the code. Sorry, you should put your config in the environment. All your config was in the code and you had to deploy out your code. And instead now it's, okay, separate that, especially with what they were doing in Heroku with, you know, running all these different servers and coordinating that with AWS and having different configs for same code bases, right? So they kind of take that knowledge, it grows larger into the community, and then .env comes out thanks to Brandon Keepers. So Brandon's probably using Foreman at the time. I don't know the story. I'd love to chat with him about it, but the first .env, he publishes it, and it's like one line of code. Right? It's like just nothing, right? Very like there's the regex, and it's just like basically split on the equals, right? So very simple, but huge, right? A lot of Rubyists start adopting that. You can use that without Foreman. You can, you know, just put it as a gem. It's just always there. You don't have to have this process running to the front, right? So kind of cool. And then it goes from, I say Ruby to Node here because I was a Ruby guy at the same time. I love .env, but I was just getting into Node. And so I was like, I want this in Node. So I published the Node one, but you've got everyone like kind of getting on this bandwagon, right? So php.env is the next one, then Python, then the Node, and kind of go down the list. So the rest is history, and it's basically become this thing that's small code, but like pretty big reach, right? That's, you know, 500 million, 500 million installs total. The Node one, just because Node's become so huge and used by a lot of front-end guys, I mean, it's almost 10 billion downloads lifetime. So it's just crazy for such, you know, started with one little tiny line of code. And it's still, I mean, if you look at those libraries still, they handle a lot of edge cases, right? And they all have a little different parsing engines, but like pretty close. But it's still not like tons of code. You know, it'd be 200-300 lines of code. It's nothing crazy. So little summary, before .env files, right? You've kind of got like pre-Renaissance, every app's kind of reinventing the wheel. Where should we put config, right? And then you have the .env Renaissance. And all this is debatable too with like secrets managers, and we can talk about that if you guys have questions. But for the focus on like development and .m files, then you've got kind of this simplicity. You've got a common approach that everyone sort of jumps on and understands and can agree upon pretty much. So what comes next? So like I mentioned, I maintain the node.env. So it's been kind of years now, 13 years of getting feedback from people, kind of what's next, what they like. And so the question I'm asking and experimenting with now is, well, what if you could encrypt these, right? So what if the .m files had some pattern in them of an encryption mechanism? And so that is dotenvx. And unfortunately, it's written in Node because I'm coming from the Node world. But we'll do a little Ruby code too. But it's also a binary, so it works everywhere. And I'll just show the tool and how it works because it is designed to be a pattern that I'm hoping other languages can pick up. And so we'll do a little of the basic encryption in Ruby today that could be adopted maybe by Ruby's .env or a .mvx in Ruby, or I don't know, we'll see. It's early, right? But so with that, let me just show it. Okay. Don't see that. 1 second. Let me get out of Keynote. Okay, there we go. Okay, so install. It is a node module, so you can install with npm, but I'm going to show the demo with some Ruby. So I'm going to install it just as a binary. So, just install from that URL. It's in there. So then you have this .mvx, little list of commands, right? But let's just say, so let me make a little app. So we'll do our, like puts hello. Right, so, hello, nothing, right? And then our .env file. All right, and usually where you'd require .m, do a .env load. Instead, this tool kind of goes back. So that's why I also said like there was Foreman, which was wrapping this. This kind of goes back to that time a little bit in this sense. But because it's a binary here, you just do .mvx run and put that ahead, and you get the same mechanism of .m. So nothing much there, right? It's like same mechanism. This could just run in my code. Why do I want to install another binary? That's kind of a pain. But the convenience you get with this binary is, okay, I want to encrypt my file. So it's just .mvx encrypt and make that so everyone can see it. And that by default will look for your .env file. And it'll drop, it gives you an asymmetric key pair, and it'll drop the private key in a .env keys file. And so we can talk about, trade-offs of that sort of thing. But in terms of the tech, now you have the public key for the asymmetric key actually in the .env file, allowing anyone who has access to the .env file could write to this file. So they might not be able to read, but they could get write-only access this way. And then you get this ciphertext, right? Prefaced with encrypted. So now you have a way to still see your keys, what's changed, what you've added, but the actual ciphertext is there. If someone gets a hold of your .env file, they don't get your secrets. They would need also your .env keys file, right? Or the .env keys. So the .env keys is really like a convenience to get started. The idea is you'd actually take that private key and put in a secrets manager, have some special process for it, for who gets access to what. But then in terms of how it works the same. So .mvx run, right? It's going to say hello world. So it's going to be able to read that private key, decrypt that ciphertext, inject it just in time. And then you get some, then if you start wanting to add an environment, right? So we'll do hello production. You just pass the -f file, right? And so that's going to say hello production, but we need to encrypt it. Right, still saying hello production, but now we've got this production key in there. It's actually production, And in the dotenvx keys file, it looks like this. So you have, a production key and your development key. And so that's it. That's dotenvx. It's just like taking a dotenv file, doing something a little more experimental with it. Obviously, this doesn't work. Like Docker can't parse this, that sort of thing. I mean, Docker parses dotenv files really poorly anyways. But you could always wrap your Docker with this. So, yeah, so back to presentation. Yeah, so that's live demo. Some people like this. They like it for the encryption. They like it because this might get out and you feel safe with it. And maybe just your infrastructure team's managing that production key. And maybe you're not as worried about the development key and you can still share that over Slack, but you're not sharing the secrets over Slack anymore. You're just sharing the decryption key over Slack. And then there's some advantages people like where they want to see in a pull request that a key has been changed. So rather than go like up to the top DevOps guy and say, hey, we need a production key added, the DevOps guy can come to the development team and say, oh, I see that you added a new key, a new Stripe key for development. Okay, let me go in there and add it for production. So there's some workflow opportunities here, the positive term, right? But there's maybe some different ways to do things here than just like top-down secrets manager by implementing this kind of approach and actually then safely committing your .env to code. So even though I was like one of the .env guys, now I'm saying, if you do this, it's okay to commit it to code. But there's more debate there too. Okay, so anyways, the actual encryption, because I wanted to do some Ruby, under the hood, it's using elliptical curve integrated encryption scheme approach to encryption. So, and I'm not like a cryptography guy or anything like that, but we're going to try to go through this. I've chosen tools that are trusted and implemented them in the tool. But the idea of ECIS is kind of cool. And I think this is the best example. So first of all, before I share the example, the way this example works under the hood is with a curve. So basically like a way to calculate a really complex number that you both agree on. And so that goes beyond my skill in sort of explaining and that sort of thing. But the way it kind of works, that curve calculation is, this is an example of paint. So Alice and Bob want to derive a shared secret. So with ECIS, you derive a shared secret that is your AES key. And that AES key is used to encrypt each of those values. So each of those values actually has embedded in it a different AES symmetric key. But to get that symmetric key out, it uses this approach. And so the idea here is, red paint with a base paint gives you kind of this pink with your public key. And for Bob, he takes the same base color. He has a different private color that Alice doesn't know. That gives him a public key. And then Alice can take her private key, mix it with the color from Bob's public that he shares. And Bob can do the same, mix it with her public key. And you end up with a shared key with two different colors. So that's the underlying approach of ECIS. So with that, let's try to do one. All right, so we're going to start with some inputs, a .env private key, a ciphertext, and I'm just going to go to some code now. So we're going to do this. We're going to start with the inputs. We're going to grab their binary form. We're going to then expand the ciphertext. So inside that ciphertext we saw, there's an ephemeral public key, an encrypted blob. And then inside that encrypted blob is kind of your pieces to build your AES key, the nonce auth tag, and then the actual content that's encrypted that can be decrypted. And so we'll do this in a little bit. And then you calculate this shared point, which is the paint mixing stuff. So there's tools I use to do that, and we'll see that real quick too here in a bit. And then there's a key derivation function with that shared point that gives you, that paint color that we saw, that gives you the AES key that then finally you can do the decryption. So yeah, let's do it. Okay, so this one I've just got kind of ready to go. Oops. Okay, so there's, the private key, and there's a ciphertext, and then we're getting the binary versions of them. And so then let's take a look at this next step. Right, and so the next step, grabs 65 bytes, and that gives you the ephemeral public key that's in there first, and then the encrypted blob left over. And then we grab out the rest from that. So we're still, now we've taken the encrypted blob, we're splitting that out with everything. And then here's the curve, which uses Ruby gem that talks to a binary that's used in some of the Bitcoin Ruby stuff. So the curve used for all this that I've implemented with all this is the SECP256K1 curve. There's other curves, so this could eventually have other curves. Right now, that's the one that's been proven pretty good and doesn't have any, like copyrights or anything like that on it. Like anyone can use it, right? Okay, and then from there, we're going to derive the AES key. So let's get that out at least here real quick. So there's our symmetric key. So, always the same, of course. And so that's actually got pulled out of that encrypted payload, right? And it was just that initial private key. And then we took all that, we got that out of there, and then we can decipher that final bit of text. So we'll run that. And we get world, right? So that's what dotenvx is doing under the hood. Obviously, there's a lot more there, especially like the SOAP and SSL, right? Doing all that hard work, and especially this, right? So I didn't want to get into all that because that's another level beyond me. But yeah, that is, so that's a little Ruby there, but you don't have to do that. There's now a gem. So there's a guy that actually maintains most of these, got in contact with him. We were working on this a little bit together because the tool I built, dotenvx, is in Node, but there's a service and that's all built in Rails. And I wanted to just be able to decrypt with Ruby versus, call out to Node or some mess like that, right? Or have the binary embedded in there. So yeah, that's it. Thank you very much. Cool. Yeah, I guess any questions? Yeah, good.
If you're making changes to an environment, you probably have secrets to access that environment. So does that mean that if you want to do some validation that file, let's say the production file, has the same keys as the development file, would that be GitHub? Would you also do like a GitHub action that has all the keys, or you do both? Or what's your strategy for verifying people aren't committing broken encrypted files?
So yeah, I think the question is kind of how do you manage these keys across different environments? Because otherwise someone might encrypt the file with the wrong key, right?
Verify that it's a valid production file that just got.
Yeah, I mean, it would break on decryption, but yeah, there's not a mechanism in the tool right now besides you can do like dotenvx get, and you can get back a specific key and see does the value come back. So right now, if it fails, the fallback is kind of in the spirit of .env and environment variables is not to raise an error. It'll just fail encryption and you'll have the encrypted string. So yeah, if you use this in production, mix up the keys with the wrong environment file, you're kind of going to be in a bad spot currently because yeah, you won't have your stripe key. You'll have some encrypted ciphertext gobbledygook. So it's a good thought to like maybe that should be added to the tool, some mechanism. Right now, people are just kind of manually doing that on their own. They'll call a get on something and make sure the value's there. So even right now, when I publish this, and publish all the binaries, I check each binary in that CI flow that it can take the encrypted file and get the value out. So, but I've had to write that by hand. Yeah.
Unlike the Rails implementation,
Yeah.
like the entire thing is just either
Yeah.
keys to the values.
Yeah. So yeah. So another good thought there is this. He mentions Rails credentials and how they're a little different, but this is inspired by Rails credentials. I'm like a longtime Ruby on Rails guy. I loved that about it, right? But then when I was doing Node, it's always like a plain text.env file. You can't encrypt it. But then yes, there's an advantage here that you can still see the key. All right. So there's this balance of the secret's safe, but I can actually review this as a PR and see there was a change there or not. Right. And then I can go make sure is the change solid. And I can even allow a junior dev to maybe commit a change, but not be able to decrypt because of that asymmetric key pair. So there's a bunch of kind of like tooling here that gives flexibility for maybe different approaches in the future. So yeah, really good thought. Good.
Mozilla secret declaration for multiple backends, they use that to the same.
So the question is, are you referring to SOPs? Yeah. Okay. Does SOPs support multiple backends? Like,
And AWS, because they use the private key, it lives in TCP, and everybody who has access to the underlying service can decrypt the files.
okay, yeah. So yeah, the question is, will this, kind of have like integration hooks or backends like SOP does? I mean, I hope so. Right now, I'm not planning to build. I mean, I would like to get to build them, but like right now, the focus is just on this core tool, but that hopefully others can come and add to that. And there's a little more here. I do have a service I'm working on, but that's like, it'll have those eventually, but right now that's focused mainly just on syncing these .env files between teams. And it's not really like built into the secrets managers yet like that. So it's a good thought. Yeah. Okay. Anything else? Good thoughts? For the gem that I've mentioned, the ECIES to use for Ruby, it does. So let me just show it real quick. Because yeah, it does have external dependencies right now. You can see it's brand new, 21st. And yeah, so you need SCCP and OpenSSL currently. Yeah. But like maybe there's a future here with it was Chris's talk, right? Where this stuff gets built in better, right? For the Ruby gem would be nice,
Or Rust crypto crates out there. So yeah,
Yeah.
definitely have some.
Yeah, and I think Ruby's a little weaker on some of this kind of tooling, So cool. Okay, maybe one more.
Could you use the SSH private key the local key to the user key to encrypt environment key? So you don't have to have a key.
No, it's not built that way because this uses this specific approach, this ECIES. So unless I guess, so maybe I'm not sure unless you can get a key pair out of that, but yeah. I'm not sure. So yeah. Okay, go ahead.
About convincing everyone to commit their environment.
Yeah, I know. I know. It's like I think the easier thing to convince right now is people using, AI tooling, especially vibe coders. Like, hey, maybe your .env file shouldn't be sitting in plain text. So I think that's the easier approach right now. And then I don't know, that it's a trade-off. So yeah. So good thought. All right. Thank you, everybody.
And now, our next speaker
is, can I also say doctor? Or are we doing this tonight?
If you want. It's
I don't know, professor, or I don't know, magician, Cameron Dutro from Cisco, right? Yeah, like
sure.
so. You guys remember his previous talks about kind of like front end stuff, ViewComponent, and what was it? Rex, Rex, yeah. So Cameron, I think, is one of those people who experiments a lot on what else we can do with the front end, what else we could do with the component system for Rails. And now we have something new from him. Woo!
What is the key you press to get your speaker notes?
How am I gonna run the conference?
You need to extend, not duplicate
Your screen share. Yes. Stop. The way I did it.
They changed it in the latest macOS version.
Nothing works. I don't know.
It used to make sense. Now it's like, assume by default, you just copy your monitor.
One of them will be.
We'll figure it out beforehand. When we have to go to a new place,
And then, so then, yes.
it gets copied.
Yeah, and then share
gonna be-
presentations.
There's nothing harder than AV
Yeah.
in tech.
Look at
Uh,
notes.
DM me, I'm a quick reference guide for the conventions that I staff.
Mm.
I probably can get you a copy.
Cool. Thank you.
That's what
I'll tell you how to do this on every device imaginable.
Yeah, and that'd be cool.
Remind me and I'll see if I can find it.
Okay, we are good to
I,
go.
I think Cameron has like speaker notes of this size on his computer now.
Yeah.
Yeah, like this.
Actually, let me stand. Thank you.
All right, take it away.
Thank you. Thank you. Thanks for bearing with me. And poor Max. That was awesome though, holding it up to the camera. Beautiful. Okay. So as Irina mentioned, this has kind of been a journey for me, like coming up with new and maybe weird things to do with the Rails front end. It comes from a place of loving the Ruby community, loving all of you, being so happy to be able to be a part of this community. And also maybe bagging on React a little bit. Anyway, it's okay. I actually like React. Always, yeah, solidarity. Okay, so yeah, I'm going to talk about this thing that I've been working on for a while called LiveComponent. It's an outgrowth of another project called Neato. That project has kind of died because I think this one's better. So before I dive in though to what LiveComponent is and what it does, I'd like to share with you a conversation I had when I joined a new company a few years ago, not Cisco. It was my first day and I was chatting with a senior dev on the team, and here's kind of how that conversation went. All right, so chatting with this guy. He says, "Hi, Cameron, welcome to Big Tech Inc. We're so glad to have you." "Thanks, senior dev guy. I'm excited to be here. I'm really looking forward to making an impact." "Great. If you have a few minutes, I'd like to chat with you about your first project." "For sure. What do you have in mind?" "We'd like you to build a little script that helps the user decide which large language model should take their job. You know, something fun and easy to get your feet wet." "Sounds interesting. I know I personally can't wait for my glorious day when an LLM takes my job." "Ha, you and me both." So anyway, if you have any questions, feel free to give me a shout. "Perfect. Actually, while I have you here, I do have a question. How do I deploy my code when I'm done?" "Oh, that's a great question. We deploy using a pull model instead of push. Just stick your code on a zip file, upload it to S3. Our prod servers will fetch it from there." "Oh, interesting. How often do they update?" "Well, some look for updates every few minutes, but some can take weeks to update." "Huh, okay. What version of Ruby is available on these servers?" "Oh, it varies. A lot of them run Ruby 3.4, but some are stuck on Re 187. Some of them don't have Ruby installed at all." "Re 187? Ruby Enterprise Edition, released in 2012. Wow, okay. I guess I could ship a statically linked Ruby binary with my script. Oh, no can do. We have a few servers in the Brazilian rainforest that only have 2G connections. Gotta keep file sizes small. Okay, I guess I could compile Ruby from source on each server. Oh yeah, no, some of our servers only have a gig of memory and a single 1 gigahertz processor. Dang, okay. I guess I could write a fallback script in Bash. Good plan. Oh, also, your script might fail from time to time because our users can run whatever they want on our servers. What? Well, how do I know when it fails? Well, you know, error messages are logged to standard out. Well, sure, but are they logged anywhere else? Nah, don't worry about it. We obfuscate our code anyway, so even if you did get a stack trace, it would just be unintelligible garbage. Jesus, can I at least SSH into these machines to see if things are working? Oh, definitely not. Some of them are owned by nation-state threat actors. You wouldn't want to go poking around inside them. Excuse me? Yep, just part of our security posture. All right, I'm late for a meeting. Ping me if you need anything. Okay, that was not a real conversation, just so you know. Okay, show of hands, who wants to work on a system like this? Yeah, nobody. One person in the back is trolling me. Yeah, nice. How much would you pay? Yeah. Right. How desperate are we to get our job right now? Yeah, you already do. That's because this is how a browser works. So let's take a couple of these points one by one here. So senior dev guy says, deploy using a pull model instead of push. Yeah, that's HTTP. Browser requests a page from the server. Tab can stay open for an indefinite amount of time. You get stale JavaScript. There's no way to force a new version onto people's machines. Of course, millions of different browser combos, operating system combos in the wild. We have lots of different device types, desktop, mobile, wearable, all that stuff. And JavaScript can be slow because lots of other things are also running on that machine, and it could even be completely disabled. Of course, we know that some devices are in super remote locations over slow, unreliable connections. Some of them are super low end, super resource constrained. These are all devices in the wild, phones, whatnot. And then, of course, I talked about other running apps and stuff on the phone that take resources away from your browser. Also, of course, browser extensions can interfere with the page in unexpected ways. JavaScript could fail to execute, all kinds of fun there. And then, of course, modern bundlers strip away symbols and shorten variable names. And so even if you do get a stack trace, it can be really impossible to read what actually went wrong. And then, of course, anyone can access your website at any time from anywhere. So they can read all your source code if it's in JavaScript, right? And then one last point is that security vulnerabilities in browsers need to be patched by the user. You can't patch those. So let's talk about a comparison from server side to client side. On the server side, we have control over the operating system, software versions, memory, CPU, disk, physical location, log aggregation, network configuration, everything you can imagine. And on the client side, we don't. We're shipping more JavaScript than ever into environments we don't control and can't properly observe. Let's take a look at this graph from httparchive.org showing the median JavaScript bytes transferred from 2011 to 2025. So in January of 2011, the median website shipped 91.8 kilobytes of JavaScript. And just this month, 755 KB is the median now. That's 8.5 times more JavaScript since about 15 years ago. Alex Russell, who writes on his wonderful blog, he's a Chrome contributor, Chrome developer, was for a while. He does a state of JavaScript. A couple years ago, he said in his blog, to serve users at the 75th percentile of devices and networks, we can now afford 300 to 350 kilobytes of JavaScript. That is 2.3 times the 755K I just mentioned, is 2.5 times almost more than the P75 baseline. You can see this happening, I think, in a bunch of places too. So Zoom, by the way, this is not Zoom's actual app. This is just Zoom's splash screen, 6 megabytes of JavaScript. Patreon, 11. GitLab, this is the login screen. This is not anything to do with a repository. 13 megabytes of JavaScript. Instagram 16, LinkedIn 31, and then for some reason, Jira at 50 megabytes. So as an industry, we need to ship dramatically less JavaScript. Raise your hand if you've experienced that the web page never loads, you get a blank white screen. Yeah, for sure. Clicking on a button doesn't do anything. The page loads, but all the UI elements disorientingly rearrange themselves as JavaScript executes. And if you, as a developer, want to pop open that developer tools, you see a bunch of red JavaScript errors. Yeah, for sure. This is all stuff that, and by the way, the normal user does not do that, has no idea what went wrong. So this is where LiveComponent comes in. So the thing you actually maybe wanted to hear about. So what is LiveComponent? LiveComponent is client-side rendering and state management for Ruby, for ViewComponent. So it augments the View components that you already have. And it's designed to replace, I say replace, it's really designed to complement these things. React, Vue, Angular, all these heavy front-end frameworks you might want to use. And it dynamically re-renders components on the server when their state changes. These renders, because we bypass most of the Rails stack, you can get less than 50 millisecond response times. And then it's small. It's only 12 kilobytes of JavaScript on the front end. There's two sides to it, front end, back end. And it also is built on sort of some of the Rails technologies that we have come to know and love, like Stimulus, Hotwire. Okay, I realize this is taking a lot longer than I expected, so I'm not sure I have time for this demo. I'm just gonna quickly show, well, I guess I have to show it because otherwise it's not gonna make any sense what I'm talking about. And I just realized you can't see that because, you know what, let's just move on. It's a to-do list. It lists to-do items. I think everybody knows what that means. In this to-do list, you can create items and then edit those items. And you might have a component that looks like this. It takes a to-do item. Oh, shoot, I have to reshare. Sorry. Yes, because I hit escape. How silly of me. Thank you. There we go. Nope, that was the wrong window to share. That's what I want. There we go. Okay, we're back. Okay, so here's your View component. If you're not familiar, the View components are just small little bits of your view that you wrap with a Ruby class. So in this one, we're accepting a to-do item, which is just an active record model. And here's what our template might look like. We're just printing out the item's text, and there's an edit button. So let's take a look at our component again. Let's say that we want to change its state from regular mode to edit mode. We might add an editing flag here and assign that to an instance variable. And now comes the magic. We're going to add LiveComponent base to our component. And we're going to change our template a little bit. Instead of that static text and button, we're going to do an if statement over the @editing instance variable and say if we're editing, then we want to display a form, and that form has a submit button and the text field. But if we're not editing, we're just going to do the same thing we did before. We have our text and button for editing. Now we define a TypeScript file at the same as a sidecar file. So we had, before this, we had our component to-do-item.rb, and we had to-do-item.html.erb, which is the template. Now we also have to-do-item.ts that lives right next to all those other components, all those other files. And inside this, we have an @live decorator on the top of our class called to-do-item component. It extends live controller. And we define a little edit method in here. And what this edit method is going to do is when the button gets clicked, it will re-render the component and change the editing prop to true. Okay. And then back here in our to-do item component, the template, we're just going to add a stimulus click handler or action rather to our edit button. So now when we click edit, it goes back to the server, it re-renders, morphs the changes into the document, and you now have an edit field instead of the edit text. Okay, the magic here is this key realization that View components can be entirely defined by their keyword arguments and their slots and maybe one or two other things. And LiveComponent works by tracking keyword arguments you're passing into your components. So in the case we just looked at, that's to-do item and editing. Records them in a state object that serializes that state to the front end. And then when the front end mutates that state and reserializes that JSON up to the server can then parse that and re-render the component, just the component you want to re-render. And all this uses Hotwire for the transport between the two. So here's what a state object looks like. Not super like maybe important, but it's just nice to see an example of like what's actually being communicated back and forth between the client and the server. You can see our editing true in there as one of the props. There's also slots and then children, which is just components that you're rendering inside your component that don't have a slot. Okay, so let's say we wanted to now submit the change. So we've hit our edit button, we've gotten our text field, we edited that field, and now we're clicking the submit button to save it. So what we would do here is simply add a re-render self to our form width, and what that's going to do is tell LiveComponent to re-render this to-do item. So that's all that's necessary. Well, I guess there's one other part. That's mostly all that's necessary. And then in our controller, this is just a basic Rails controller. We're finding our to-do item. We're then updating it. And then in the template for our update method, all we have to do is say live.re-render, and we can set our editing prop back to false. So we updated in the controller, and now in the template, we're saying re-render my to-do item component, this time in non-edit mode. So now we can say, I want 3 phenols, update to-do item, it'll post to the server, and then re-renders that component in non-edit mode. Okay, so well, we'll see if I can show the crossword demo. This is kind of important to the demo, so 1 second, let me just put the mic down. And I'm going to have to fill this server.
No, don't. Just drag from one window to the other.
No, it's VS Code to the browser. So yeah, I don't know if I'm going to be able to not share. We're stopping the share. Okay, there's my browser. Okay, so this whole thing is written with LiveComponent. I'm going to, and hope to God that it works, live demos being what they are. I'm going to open my network tab, and this is just a crossword app. So you can see there's like a clue down here, young person. So if I type Y here, this re-renders on the server, OUTH, and you can see that after the first couple of requests came in, they were a little slow because it was warming up. Now they're pretty fast, and I can keep going. Let's see what this is, Arial font. And in development, it definitely has, like, there's something going on with like eager loading or something, or like lazy loading, where like it thinks classes have changed. That's what you're seeing whenever the number jumps up to like 136, because I'm in dev mode. I tried this on Heroku in production mode. The numbers were also pretty good, like less than 50 milliseconds per update. So T, Eli Manning, here, and we're done. Okay, so one thing too that you may know or may want to know is that timer over there is not actually updating on the server. That timer is a React component that is, because LiveComponent has an integration with React, so you can mix the 2 types of components if you want. But yeah, all of that was happening via state updates that were being rendered on the back end. Okay. All right, so you can see a half-created documentation site at livecomponent.org. There's a lot more coming there. I'm only one man with 2 children, so please. And you can also check out the to-do app demo, todoapp.livecomponent.org. That has actually been compiled to WASM using Vova's awesome work, because I did not want people to just put any random stuff in my database. So it runs entirely in your browser. But you can still see the network tab and see what's happening behind the scenes. Yeah, and then I also have not published the code for this yet. It's still a work in progress, but that should happen hopefully very soon. Thank you. All right, I don't think we have time for questions, but talk to me after if you want to chat. Okay, and I'll just transition to my other role now as introducer of people. We are now going to hear from the inimitable Miles Georgi about AI-backed domain logic in Foobara.
This. So I'm going to be doing a couple code demos.
Miles is connecting a Linux machine to the screen share.
I know.
It's always a little bit dicey, but we just everybody, yeah, think positive thoughts.
Is there a way to like make this annoying thing go?
Pray to Richard Stallman.
Oh yeah, yeah.
Not pray to the wet.
Do not pray.
Do not pray to the wet rat.
Do not. Who's the wet? Oh, Richard Stallman's the wet rat. Okay. All right.
Oh, I got.
Oh, you got the lob, right? Yes.
I guess this is working, right? I can kind of hear myself.
So you can't turn it off. Sorry.
Oh, what's that?
It's local, so it's
Oh.
not, you would have to do in whatever's displayed. You're asking how to turn the thing off in the top right.
No,
No.
no, I turned it. I found it.
Oh.
Yeah, it was a
You
button.
probably heard it on your screen, that's not projected.
Oh, yeah, yeah. So I saw everyone's face in the Zoom. I found a way to hide that, and then all the controls were there, and I found a way to hide that. Yeah, because it was on top of all this. Hey, but my name is Miles Georgi. I built a software framework called Foobara that I've talked about here before. This is a service I had built way back in March, and I decided to circle back around to it and make it a little more closer to something functional and useful. And it's built with the framework itself. So a lot of the forms you're going to be seeing here were actually generated from the framework. And yeah, I'm going to actually just dive right in here. The purpose of this service here is to give kind of a no-code-ish way of creating commands that do not actually contain domain logic. So in the framework, the purpose of a command is to encapsulate a high-level domain operation. And using LLMs and using agents, there are certain situations where we can actually encapsulate a high-level domain operation and allow the LLM to carry out the domain logic instead of writing the domain logic ourselves. I've got some links down here to make the demo go a little faster, so you don't have to watch me type all this. I'm going to make a different command here real quick. Let's do compute. Actually, let's run this command. I've already created this command. This was a command called compute. And this was the description. You can't see these anymore because they've been filled in, so the placeholders are gone. This is the input type, and this is the return type. Right now, I'm just using YAML, but it would, of course, be cool to have some kind of WYSIWYG editor to do your modeling. And I've put together a script over here that's going to make use of that. So I'm importing the command from CommandForge. And this is actually not the right script. So one second. It's this script. Okay, so here I'm importing the command from CommandForge from this domain, an AngelList domain for this demo. And I'm just going to call the command directly at first. And this is a command called compute. I'm going to try raising 2 to the power of 3 with an LLM, which is a really stupid use of an LLM. And this is using QEncoder the 30B, so it takes a little while. And there it is. It spat out an 8. So let's jump back over the code here. I'll go ahead and just roll with this command for a little while. I'm going to comment this out. And one thing you can do with Foobara is once you have a command, you can connect it to command connectors. And there's several different command connectors. And these basically abstract away integration code. Here, I'm going to go ahead and expose this command on the command line. So I'm going to go ahead and connect the whole entire domain to the command line. And then I'm going to run this again. And so now I get some output. So here's my compute command. I'm going to go ahead and get some help from it for it. I'll do help. And this is going to, oh, you can see all these LLM models. So you can choose a different LLM model if you want. That's pretty overwhelming. But up here, you can see operand 1, operand 2, and we can pick any of these 5 operators. So I guess I'll go ahead and try running this. Well, let's do 2 to the third again. 2, 3. And actually, I'll just do regular multiplication. And we get 6, which is what we expect. And I get type checking and input validation for free. So if I try running this with operation instead of operator, it'll tell me that. Yeah, so I'm going to jump back over here. Oops, that's not it. So Zoom is on top of my browser. Let me find my browser. Okay. And I'll go ahead and make this bigger. So I'm going to create this is a command that actually had a real world use case. Needed to take a phrase from an email and translate it into a date. So this is a command that's going to do that. There's sugarier ways of creating these types. And when you're writing Ruby code and creating these types, it just looks like normal Ruby code. I should probably show some of that a little bit later. I actually have 2 demos prepared. I don't know if we'll get to the second one. In the second one, you'll see the code. But yeah, regardless, what we want to do here is just take an English phrase and translate it into a programmatically usable Ruby date. So I'm going to go ahead and run this again. Oh, I didn't create it. Sorry. I didn't actually press the button to create the thing. So I'm going to press this button. That should create it. Right now, I just get the ID number of the command, which is not the greatest. What I should do is like output a script, other information, of course. Okay, so I'm going to run this again. So now we have compute and determine relative date. So I can get help with this one. Oh, I have to do -demo. Okay, so pass in a phrase and we have to pass in today's date. So let's go ahead and try running this phrase. And I want to say, let's try the 3rd next month. Now, unfortunately, I do have to pass in today for now, but I'll show how to not have to do that moment here. Date. I do not have these date formats memorized, by the way. Okay, and that's when RubyConf is. So get your tickets. SF Ruby. Yeah, SF Ruby. Yeah, SF Ruby's RubyConf. And yeah, it gave us the correct date. The person who was using this, they started adding some regular expressions so that they don't have to wait forever when it's something like just yesterday. But yeah, so I'll go ahead and show something I actually went ahead and wrote today is an input transformer specifically because that today thing was annoying me while I was working on this. So I'm going to show how to use an input transformer right here. I'm going to go ahead and just set today. Oh, you know what? Before I do that, let me undo this because there's something else I want to show. If I do this, I can do describe, and I can actually get the metadata for this command. So I wanted to show this first. So here I can see that the phrase and today are both in the inputs, and they're both required. And then up here, you have like a bunch of possible errors. There's a lot of information in here. This is the data that's used for these to be called across systems. And this also works in TypeScript. In the browser, it's actually TypeScript versions of these commands calling the backend. So this metadata is what actually drives everything. Point being, I want to get rid of that today date. And I'm going to do that by using the inputs transformer. I'm just going to flat out set the date to today. And something that is cool about that is, something that's cool about that is that the metadata actually reflects that. So I could actually export this command elsewhere. Someone else could import it and they wouldn't even see today because today is now no longer in here. It's gone. So I can ask that transformer the type on both ends. What's the type before? What's the type after? And that can be used to stitch all this stuff together. So now I should be able to run this without passing in the date, today's date. And November 19th again. Okay, cool. So coming back over here, I'm going to, trying to remember what I want to do. I'm going to go ahead and just bring back, I'm going to undo this because now I want to create a much more complicated command. And this is actually going to be surprising that this works. So, oops, this is not on the right place. So one thing I need to do, and you can't see them, but the zoom controls came back for some reason. I'm going to hide them again. Okay, so I need to create a create type tab as well, because you can also create types, including entities here. If you create an entity, you automatically get a bunch of commands for mutating those entities. But I have it working on the back end, but not the front end. And that made me realize that what I can do, because this is built using Foobara itself, I can actually just write a script to create the types if I want to. So I'm going to demo that here. So here's create type. These are all the commands that this front end, it's a React app on the front end. These are all the commands that it's calling to do the things you're seeing in the browser. So if I come over here, I want to create this command here, but it requires this model here, and I don't have a good way to create this model. So I'm going to create it in a script. So let me jump over to that. So here's the script here, and this is going to be kind of ugly to look at because this is just raw metadata copied and pasted in here. And I could clean this up a little bit and make it a little sugarier, but there's no real point. So I'm going to try to go ahead and create the model in the other system that I need to create in order to be able to create the command I want to create. So I'm going to call create types, and I'm going to cross my fingers because this should work. Okay, so it did work. If I go over to, and I still have the browser in the wrong spot, but that's okay. If I come back over here, I should now be able to create this command, and I have. So I am going to get my list of commands again, and I should have this command. Oh, I guess I should have talked about what the command does before I created it. But this is going to be a command that is going to analyze a sentence. So we can see the command here. It says analyze sentence, accepts a sentence, and analyzes and spell corrects it. So what it's going to do is find the verbs, the nouns. It's going to give you the uninflected form, tell you the subject and object. Let me jump back over to the browser to show you that. I'm going to just click this. Oh, you can't see it because, yeah, there's no types over here. So I'll just come back over here, but I'm going to go ahead and run this analyze sentence command. Well, first I'm going to get help because I actually don't entirely remember its interface. Okay, so it just takes a sentence. So pretty easy. Let me think of can't remember the sentence I was demoing it with, but Miles wants, I'm going to put a typo there intentionally to show you he's another typo. And this is also using QN30, which takes a little while and probably doesn't give the best results, but we could also try it with Claude if we want to. So yeah, so here I get the output, and this output can be used programmatically. So we can see the original sentence, it gets automatically corrected, and we can see here's the verb. Ooh, that doesn't feel right. So I'm tempted to try this with Claude just to see what happens, but I'll do that in the next part because what I want to do is jump back over to this script. I want to show you how it can be used programmatically. So instead of connecting it on the command line, I'm actually just going to call it programmatically, and I'm going to do that down here, and I'll use Claude this time. So, ooh, that's too much stuff. Okay, there's some spoiler alerts spoilers at the bottom there. So yeah, so here what I'm going to do is I'm going to call analyze sentence, and I'm going to pass it this sentence here. And I'm going to actually print out the original sentence, the corrected sentence. And here I'm just actually using this like any other model I would get from any other command where I was the one who wrote the domain logic. So let's demo that. So now it's just a script again, because I'm not connecting it on the command line anymore. So this is that output. So, ooh, look at this. Oh, it's on the next line, that's why. So this is the original sentence. This is spell checked sentence. And you can see that it's actually this model. And it's the uninflected form of the first verb is want, since that's what we printed over here. So yeah, what I could do is show using it over HTTP. So you can use this stuff over HTTP, the command line. You can use it over MCP. What else? You can use it with rescue. So the point of the framework is not AI stuff. It's that you should be able to express your domain logic. And then if you want to call it asynchronously, you shouldn't have to then go write a job to do that. Or if you want to call in the command line, you don't have to write a rake task to do that. And this just helps not smear your domain logic all over the place. But I'm going to go ahead and expose this one via rack. So I'm going to do that now, which, yeah. So I'm going to run this. And then I'm going to have to go find my browser. Is it here? Oh, it's probably this one. Oh, okay. So some spoilers here, but I can show I was already on a help page, but here's the raw manifest. Oh, I have a typo. Okay, so here's the raw manifest. I can collapse it all. And so we went ahead and exposed the whole domain, so I can see these three commands here. I can see whatever I need to know about them. Like I can see all the possible errors that can happen. This is what like the code generators and stuff use. Yeah, and then as you just saw, you can also get help just like on the command line. So here I have analyzed sentence. I can see it gives me an analyzed sentence model. I can see these types, language is a type. So this is a custom type. I don't think you'll see anything if you click here. Yeah. So I haven't worked on, you can see that not a lot of love has been put into this specifically, but it's just kind of cool that it's easy to expose this. And this actually comes in helpful once in a while when, if I'm in the browser and I just want to see what something looks like, I can do it. Yeah, I think that's the end of this demo. Yeah, I believe so. There's not much else to demo with this one. Yeah. Should I try to move on to the next demo or not? Or should we just have questions? Because we could just stop here.
We're at 8:15. We're a little over.
Yeah, let's just go ahead and let's just go to questions. I guess the one last thing I'll say is the next demo is going to demo agent-backed commands, which they actually operate your domain, like an agent would. And so I have two types of commands that do not have domain logic. One is the LLM-backed command, which is what these are. This is for extracting knowledge from an LLM or having an LLM make a decision, whereas the agent is actually deciding what commands to call to accomplish a task. Yeah. So you can kind of picture what the second demo is like. Yeah, so I guess any questions?
How did you get it to respond with JSON? You asked the LLM. I analyzed this. Sorry. I was asking how you got the JSON output because LLMs generally just produce like a wall of text, right?
Oh,
so
yeah.
you were showing that like when it analyzed a sentence, it said, wants was one of the verbs, and it was showing that in like JSON.
Yeah. So I guess I should just show the code or whatever, but no, it's not that magical. So basically what I do is I take the Foobara type. and I translate the Foobara type to a JSON schema type. I don't even know if that's necessary or not. It's just something I do. I assume that the model has been trained on JSON schema. There's no way it's been trained on this schema. Yeah, so I translate between the two, and then I tell it, I basically say you're only going to respond with one thing, and that one thing must match this JSON schema. And the better the model is, the more likely it is to get it right on the first try. I think I give it up to 3 tries. The crappier models will kind of try it. When it fails, I tell it why it failed and give it, a couple more tries. And usually by about 2, even the weak models can get it right. But yeah, basically, long story short, I tell it, this is how I want you to respond. And this is the only thing you're going to respond. I don't want like a big essay about why you came to this conclusion. I just want the conclusion. Yeah.
Don't give me this in this format of busful children.
That's right. Yeah.
To be like really overly reductive though, doesn't this seem kind of like, I guess, some JSON schema into like a tool calling just like agent loop?
This here is not an agent loop, but the agent back command is, and the agent back command, and I've showed the algorithm before in a previous chat, but basically it's really simple. The loop is until you have accomplished the goal or given up or had an error, you need to determine the next command name and inputs. And that's an LLM backed command that makes that determination, that makes that decision. And it's just and then you run that command with those inputs. And all the agent is just a loop that just does that. So this can't do that, but the agent back commands, that's exactly what they do. And it's a surprisingly simple loop. Like what these agents do, I'm sure there's tons and tons of optimization, but to just get a basic agent working, it's really just, here's what's happened so far. Here are your options. What do you do next? And one of those options needs to be, I'm done. And that's basically all it is. Or at least that's all mine is. Mine is virtually very little more than just that. Yeah.
Must the commands be LLM based?
No, normally they're not. So no, normally I write my own domain logic.
Well, you would have a command that it just says like does map and it doesn't make LLM do math.
Correct. So you just write an execute method and you add the 2 operands.
Okay.
Yeah, that's normally what you do. This is not the typical use case of this stuff. Yeah. Yeah.
For more information, see Miles' previous talk at Meetup.
Yeah. I actually have a video on YouTube of it too, where I explain, I go about explaining something I discovered, which is just that domain logic couples these code units. And if you have a command without domain logic, you can actually change its interface without having to change anything else to it. And if you change the interface of a command, any commands that don't have domain logic also will not break, because it's all negotiated at runtime. So if you have no domain logic, then it's just figuring out what to do at runtime. It doesn't matter if you change the interface or not. Whereas if you write the domain logic, you will break it if you change the interface. So that's like an interesting thing that I made a video about if you wanted to check it out, which is something I'd never thought of. I've never thought domain logic is actually what's coupling these types of code units, but it's true. If you have 2 high-level domain operations, it's actually the domain. It's not the interfaces, it's the domain logic in them that's coupling them, which is like counterintuitive to me, but yeah. And I think, is that it?
I think so. Yeah. Thanks, everybody. Just quickly. Oh, yeah. Let's applaud Miles for sure.
Thank you. Oh, I should have mentioned. Look at this. I also wrote my own .env thing. So good.
Yeah, Scott had off. Yeah, he had to
could have
catch a flight, I think.
add this to the list.
Yeah, exactly. I wanted to remind before Irina closes us out, which you are planning to do. No? Okay. I will close us out. If you have a talk proposal, please submit. We're looking a little thin on talk proposals. There will not be a meetup in November. Our next meetup, I think, will be in December. Yes. But please come to the SF Ruby conference. It's going to be awesome. Yeah. The 19th and 20th of November. Yes.
Save the 23.
Yeah.
Okay.
Sure.